Alrighty, good evening everyone. This is the Coding Together stream. It is a weekly live stream in which for 1 hour you get a front row seat into how a professional software developer goes about solving problems and writing code. I am recording this video on Thursday, April 6th, 2023. My name is Savanni. I'm a staff engineer at 1Password. I learned to program when I was 12 and I became a full-time developer right at the very beginning of the dot-com bust of January 2000. I have been up and down the entire software stack from as low as individual logic gates to as high as building GPUs for GTK and the web. Last week, we were working on an application for playing and recording Go games on the computer. This is going to be a multi-platform application. Right now I'm only coding for Linux and GTK, but my next platform is going to be Android, and in fact probably I'm going to start trying to figure that out in just the next couple of weeks. Tonight we're going to finally take the step where we're going to actually put a stone on the board. Last week I got drawing on the board. I was able to write ghost stones or draw ghost stones onto the board. After my stream, I actually even got a much better board texture, basically by finding a nice large piece of wood in my house, taking a picture of it, and then scaling the picture down until it fits. So we're going to start with that. Not going to be a lot of exposition tonight because there's a lot of architectural stuff that I'm going to show you, but I'm going to show it to you as we work through things. And watch -X run. There we go. Here we go. I'm gonna switch over. I'm gonna keep my camera turned off again tonight since that seemed to help with the some stream latency issues last week, but I've also downscaled so that maybe, hopefully, there's no interruptions. So let's flip over to some live coding. And here we go. As you can see, I got a texture. We are at the point where the only interaction so far is being able to just mouse over a place, and it shows a ghost, a transparent stone, where clicking on that place would actually make the stone appear. So let's get that out of the way. That's just going to be in the way. I'll probably need that back later. What we're going to do now is actually get to the point of click on the stone, make something happen. As you can see, I just clicked on a space a few times. We've got a little bit of output on the standard output. Diving into the code. Where am I? Yeah, good. Actually, let's make this easier. So this was in, right, we're in board.rs. Okay. And we're going to want the, oh, that didn't work right at all. We're going to want to have the data types that are involved. So Kifu core types.rs. Is this it? Nope, this is not quite it. Not quite it. I promise one day I will get organized. What's going on here? Source, UI, playing field. Oh, did I know? Where's the board element? What is going on here? This is game. Oh, I'm in the wrong types file. Wow, that was fun. Okay, maybe if I actually write some documentation, that'll be easier to recognize. So last week, I introduced you to the board element. This is the basic data structure that describes where everything is on the board. This is not really the data structure that we would use for processing a game or playing a game programmatically. This is actually the data structure that the core of the application uses to communicate the current board state to the user interface. and the user interface receives that, keeps it stored away, and then during the draw routine, which we have down here on the drawing area, it references the board pretty heavily. There are certainly, well, maybe not, there are certain portions of the draw routine that are static. They would probably be based on certain settings, but they're not really referencing the data that we get back. Most of that is being done right down in this little block of code, where anytime that we find, now it's called an intersection element, that is filled, we have a stone color, so we're just going to draw a stone there. That said, we have an empty board at the moment. There aren't any stones in the game yet. Now, the way this differs from last week is that there's now, it used to be that this was just an indicator of whether there was a stone, but now it's actually an indicator of 3 different possibilities. The first one, of course, is there is a stone in this location. Another one is that the location is not playable. Now, I'm not emitting any of those right now, but the rules of Go are such that there are times when you simply cannot play in a space. Usually that would be a case of self-capturing. And then there's this one, the empty one. This is where all of the stone requests end up. That ends up looking, because I print the entire board out, that ends up looking like a great big array of these. Each one of these is a request. The contract that is being enacted here is the core tells the user interface what can be done in each one of the spaces. The user interface knows that whenever there is an empty unit which has a request, then clicking on that unit means that it needs to send this request back to the core. And that's the part that we're going to do now. Had some fun when I was working on this, figuring out how to actually capture that click. It's not actually incredibly obvious in GTK4. Several weeks ago when I was working on the hex grid application, I figured out the motion controller, which is how you find out where you're actually located on the drawing area. It's really the only interaction you have with the drawing area. Well, it turns out in GTK4, all clicks, basically everything that's not motion with a mouse, anything that's clicking on something, is done through a gesture controller, specifically in this case a gesture click, because GTK4 is constantly moving more in the direction of being compatible with touch-based devices. What wasn't obvious is that, like, when I was looking for another event controller, I was expecting something like event controller click or event controller gesture, and that's not really how it worked. But it does turn out that this structure implements the event controller type, and so we're able to add it right here, so that the drawing area now also knows that it has an event controller for handling gestures. And right now, the only thing we do, we are specifically getting click gestures, and the only thing we're doing is printing out the request that's going to be sent. So let's send the request. To do that, I'm going to go back to the main application, because this is some kind of heavy stuff that I wrote several weeks ago. Seeing as this is a GTK application with a whole lot of asynchronous operations, I have architected it such that GTK itself gets the main loop, which, if you don't know, GTK requires that all of its rendering, all of its event handling and whatnot has to happen on the main loop. The UI is basically not safe, or not thread safe. So I put that onto the main loop as well as handling all of the events, and then I spin up a Tokyo runtime for handling the actual logical operations that happen in the background. I made all of the core operations asynchronous. In fact, we'll pull that up at the same time, of which there's only one operation right now, dispatching a request to actually retrieve the current playing field. Um, why do I have run? I don't think run is a thing anymore. We'll find out. And then I created what I'll call an API, or what I'm just calling an API, which is the way that GTK gets to interact with the core. There's a couple of layers of indirection, and I don't know that it's the best. It was kind of tricky to figure out, but anything that has hold of this core API structure can, using a GTK channel, send a message, and then that, am I going to need a receiver? I might need a receiver. Yeah, we're going to have to come back to that. Might need a receiver. Might be in some trouble there. Okay. Keeping a Tokyo runtime right here. And then in the dispatch, the whole thing here is spawn a new task. That task requires the channel. It also requires the core itself. And we're just going to send a message to async move. Wow. Okay, hang on. Huh. Yeah, it's been weeks. I've forgotten how this works. And since I didn't document it, let me find where I use dispatch. API.dispatch, we're putting a message into it. And then the request. Oh. This channel right here, this GTK-TX, this isn't actually for communicating with the core. This is how the core communicates back to GTK. If we scroll down to where it's created, right here, the GTK RX is the other side, and that's the one that receives responses from the core and dispatches them out to the user interface elements. Sorry about that, a little bit of confusion. So the dispatch operation, again, it's going to spawn an asynchronous task, which needs hold of the sender, and it needs hold of the core itself. The core will do the processing, and whatever result it has will get sent back to GTK along this channel. So, let's get started. First of all, I'm realizing that the request that I created, the request data structure, actually needs to be defined in here as part of that enumeration. So let's grab UI types.rs. Let's grab the correct one for avoiding confusion. So a place stone request. Yeah, I made this as a standalone structure. So what we're actually going to do is I'm just going to make it a field here. Or actually, I don't know what to call one element of an enumeration. And I'm actually going to stop abbreviating that word. Okay, so there's the place stone request, which is not being instantiated yet, but we're going to come back over to here, delete those, and then whoops. Always with me, there are unpredictable key presses, as I just failed to hit the correct location on the keyboard. So for each column, we want what is in the current column and row. So we're going to ship that up to the user interface. except that request, of course, is not yet in scope. Let's see if I can include that. I think I can. I'm worried a bit about, oh yeah, okay. No, no, no. Oh, there. This is a data type right here, not the exact value of any enumeration. Why is this blue squiggled? Does not implement copy. Well, that's easy enough to fix. Clone, copy, debug. May as well get partial EQ and EQ as well. In the response, I'm also going to make clone. I don't even want to type those out. I'm going to copy them. Later, when I start adding the Android, copy may not be... Oh, okay. We'll fix that too. Later, when I start adding Android, I'm going to need to add deserialize to this and serialize to this. But we're not doing that yet. So copy can't be implemented there because the playing field view does not have copy. There we go. Handle that. That's going to throw a bunch more errors, bunch of things that don't implement copy. I think I kind of learned recently at work that implementing copy on a lot of the simpler data types is just kind of a good idea and might even just be good courtesy. Oh, that's interesting. Why cannot intersection element implement copy? Vec does not implement copy. Oh, that's difficult. Okay, gotta backtrack. So the request can still do it, but the response cannot. Probably have to take those away too. Guess I'll add those when I need them. Yeah, it's still angry because I've got the playing field. I'll take that away and just hope I don't need it. Match request. Okay, so now of course it's warning me that I'm not actually covering all of the patterns because I've added this new request type. So let's do that. Dispatch request place stone request column and row. We're just going to print for the moment. So I'll get my syntax right too. I might get my syntax right. Oh, but I still have to give a response. Well, I know that the response is going to be the playing field again. It would theoretically be an updated playing field, but I'm not updating it yet. So we should get a little bit for, actually we should completely compile. Yeah, there we go. So now we need to go back to the user interface. We need to provide that API to the board itself, and then in here we basically need to call API.dispatch the request. I'm going to keep both of those. And that's still not going to be enough because we're not actually doing anything with the response. So let's get the API to here. First of all, let API equal self.api.clone. Now I have to add the API to the storage. And it's basically going to be present from the beginning, so no ref cells involved here. Ooh, wow. Okay, I need to actually move the API, because right now it's defined in main, and you can't import main into anything else. So let's grab all of that. I will move it into the library. Okay, this is going to require that I move a bunch of definitions over. So far, so good. Grab the Tokyo runtime. I'm not going to need all of these, but I'm not to the point of doing delinting yet. Okay, apparently I am. Okay, so far so good. Good, good, good. Let's see here. So now I need to, oh, right. If I want the API to, the rules here are a little bit different. Even if I want the API to always exist, there's no way to pass that into the new function for the private board. So I do still have to keep this as a ref cell. I don't like putting it at the top. The top should be, here we go. The top should be the board itself, and then the next section should be all of the state that the board keeps track of. Save that. Now I have to make sure to import the core API. I am not importing anything from a crate yet. So use crate core API. Good, that's working so far. Oh, I really hate doing this, but this actually has to be an option, doesn't it? Oh, gross. Gross, gross, gross. Can I... So what makes the option here so onerous is that it basically means I am going to have to, for the rest, or for everything else in this class, before I can call the core API, I have to verify that it's not, or that it's actually present. That's actually really annoying because by the time any of the rest of my code runs, the API has to be instantiated, but there is no way for me to pass that in to the actual constructor. So I think for the moment I'm stuck with this, but I may be able to find some help on that. Okay, that's good. Now I'm going to jump down to the constructor for the entire board, and for new, I'm going to make sure to add the API. Do I want to reference? No, I'm just taking a full clone of it. Okay, so what is this? S.attach. Attaching. Okay, that's how you add something to the grid. That's fine. S dot go to the implementation. The API equals API. I think that works. Nope, not quite. I think I need to dereference this. And it cannot be... Bar mute? Does that work? Yeah, that works. Like the API is an RC ref cell, so I need to borrow it mutably and assign some API to it. So now we go back to where we are actually calling into the API. So in this case, the API, I am going to yeah, I guess I am just going to clone it again because reference counts can be cloned. But API, no, we're going to say match API okay, I think it's page down that I just hit. Do I really want to do this? What do I do if the API doesn't exist? Actually, I think I panic. And there actually is no response here. The response from the core goes channeled around through a different path. Specifically, that channel that I was going on about earlier. So let's see here. So the API dot borrow dot accept, or not accept, expect. And there's not going to be a response here. Okay. Everything's looking okay now. So let's run this. That's weird. There we go. Right. I have to actually pass that API around. So we're going to go to the playing field widget here. Yeah, this is going to be trouble. So much trouble. So now that the API is a requirement, I have to do the same kind of staged building with the whole playing field. I'm going to rename this right quick. Ugh, gross. Why did I do this? This is 100% not needed now. So we'll take that away. Okay, good. And come over here. Gobon no longer exists. It's called a board. Scroll down a bit further. Right. Yeah, that's got consequences, doesn't it? Okay, we'll come back to this in a moment. I'm just going to get the board, or get the API added to the board. Oh, okay, yep, this is great. Yeah, this is exactly where that happens. API is the core API. Okay. I'm not going to hold on to it in the playing field. In the future, I probably will, but for right now, board borrow mute equals new. What language was that? Board new with the API. And it needs to be some let's include the core API, which comes from use crate. So far, so good. Now, here we go. These functions all potentially fail. This is really gross. I actually really dislike this. What can I do differently? I think at the moment I should do nothing differently. I should just solve the current problem. Cannot move out of dereference. Option board which does not implement the copy trait. Oh no. Unwrap actually consumes the option. We can't consume it. The board actually needs to remain in the whole data structure. So I think, yeah, we're going to map, because map lets me perform an operation within the option. In fact, I might not need to borrow anymore, because that might work implicitly. However, yes, I do. So we're going to borrow. Now, why is it angry? It still thinks I am moving the value. If I just take a reference there. Okay, now's where I actually need the full error messages to figure out what's going on. Let's get rid of that for the moment. Save. Okay, show me the error. Consider calling asRef or asMute to borrow the type's contents. Move occurs because type option board does not implement the copy trait. So what do I need to be borrowing? This doesn't feel right, but it worked? Okay. Okay, so I'll have to do something similar here. So if the board exists, board.borrow.asref.map we'll do this. Okay, still doing okay. Looks like there's a problem elsewhere, but we're going to come back to that. We're going to finish this up. So again, I'm going to do an operation like this. In fact, I'm actually going to move this down to here. And I'm even going to combine these two operations. So we've got a board. We're going to set the actual view. I'm going to rename this, or sorry, I'm going to rename this part soon. I haven't figured out exactly what to. And now we're going to set the current player. Okay, there we go. And now I have to go back into the board because apparently, yeah, I'm violating the same borrow rules here. So if I've got the API, I want to borrow it. As ref, I'm not. Maybe that works. There we go. Still not quite there. Gotta go to the main now. Line 74. Get some stuff out of the way. What is happening? Oh, okay. Okay, so I need to pass the API into here. I believe the first argument, yeah, is the API. So we'll do that. It's gonna need to be a clone. And I've got something wrong still. Core API and Kifu GTK Core API have similar names but are actually distinct types. That probably means I forgot to delete this. Good move. When you delete a data structure from someplace, or when you move a data structure from one place to another, you have to actually delete it. Core API, I appear to not, oh, wrong place. I was trying to import Core API from the Core crate, which sounds intuitive, except that the API is specific for a Rust client. There's going to be a different API for the Android client. I've still got a borrow checker problem though. Line 65. I am moving the API. So instead of cloning it in here, I want to clone it right up in here. And like this is a, oh, did I get it wrong? The captured outer variable needs to, right, I do, oh, I've run into this before. There's a captured outer variable. It's being captured by an FN mutable closure. Oh, that's not great. That's really not great. It doesn't like, oh, okay, no. Okay, so like the whole problem was that with this line, with this right here, I would clone the API and then I would move it, like right here, I would move it into the closure. Cool. This closure can be called multiple times. In fact, it's going to be called many times through the application. But then I was moving the API again. So this move means that this outer one was not ever going to be available for future iterations of this closure. So what I actually need to do is to just clone it again right here and pass the clone into the playing field. Okay, now something else is angry. Oh, okay, data structures are private. That's easy enough to fix. We're just going to make these three public. Don't touch anything, don't touch anything. Great, and well, that's, oh wait. I was gonna say that's no good, but in fact, standard out was updating so quickly I couldn't see it update. So this is the UI saying which request it's going to send. This is the core indicating that it's received a request. That's pretty sweet. I'm gonna stop printing the messages because that's kind of getting in the way now. Where am I? Here's the playing field, here's main, here's the message. Just gonna take that away. Make it more obvious. Boop, boop. There's definitely some quirkiness. Like I can click on this and I can't click again. I need to, yeah, it's not responding to additional clicks. It's like needing to, I'm not sure what it's doing, but I know that all of it is because I'm not updating state in really appropriate ways. Everything so far has been kind of quick and dirty. In any case, now let's go to the core. Let's actually process this thing. We're going to dispatch, we've received a request to place a stone at a particular place. In the past, we have always just created a new playing field. Instead, now, we want to update the state of the application. This is where it actually becomes an app instead of just a massively over-architected display system. Okay. So the app state is part of the core app. It is shared and locked. What we want to do is the only thing it stores right now is a game state. So we're not yet dealing with the complexity of being in a whole lot of different states. So I'm actually just gonna make it simple. We're gonna say place stone, and it's still gonna be gonna make a subtle change to the request data structure actually. So pub struct play stone request. Gonna make all of this will cause problems over where I generate the structure, but the UI is not going to care at all. It's really not. And the reason I'm doing this, though, is so that now use crate that it is public. Good. Now this method doesn't have to take a request, or it doesn't have to take the big generic request structure. It can take just a playstone request. Oh yeah, need to include self. Okay, that's good so far. There is not going to be a response from here yet. So we've got the playstone request. I'm going to take all of that out. I don't have to destructure it anymore. So self, no wait, yeah, self.state.write.unwrap.placeStone. So far, so good. Except that we're not returning a playing field yet. We'll get back to that. I need some water. Now, I'm going to do a playstone request. We're going to be naive. We're not going to check any of the rules of the game. We're just going to put a stone there. So, self dot, is there a game in progress? If there is a game in progress, yeah. How do I want to express this? Yeah, okay. Self dot game dot map. I guess I have to make this mutable. Not even dot map. Match self dot game with some ref mutable ref game a thing, and none. We're just not going to do anything. All of that is okay. Cool. Now come down to the game state. Oh, wow. Oh, no, actually, this is appropriate. This is a good... This right here is a good well, it's almost a good representation of the board. Huh. Better representation is a single dimensional vector UI types.rs. Come back over to here. Oh yeah, this is the part that needed to be fixed. One moment. The thing is, the board that I want to store here is very similar to this board, where I've got a size, I've got all of the spaces, and importantly, I have this little function which goes from a row and column pair, and I really need to reverse that, but I go from the row and column pair to an exact address within the board. So I'm going to duplicate some code right now, but between now and next week, like basically not on screen, I'm going to abstract, this so that basically I can have the version that stores the intersection elements and is designed for going to the user interface, and I can have the version that just stores the colors. Not at the moment. Pub struct, no, we'll just say struct board is size, spaces, vec, color. I'm gonna grab the address function. I'm going to go ahead and reverse this because it really bothers me. In my mind, I always associate column, like, at least in the US, we always say like row column. But then when we're talking about like matrices or things where we think in terms of rows and columns, but when we think in terms of pixels, we talk about X and Y. Well, X is a column and Y is a row. And so it bothers me that we've got things reversed, to be honest. So I am going to, even though the code is inconsistent at the moment, I'm going to start fixing that in my code. So this just takes, it's a really standard function, or a really standard calculation that takes from a row and column, and then it uses that to figure out the index within an array. And now, fin place stone. It's really angry about a lot. Oh, right, you can't declare methods there. That was fun. We're going to place a stone. This is going to be mutable. Column, U8, row, U8, color, or stone is a color. And we're just going to say self, or let adder equal self dot adder column row, and then self dot spaces. That's really silly. Option color. I didn't make this variable tri-state, did I? No, I didn't. I can't believe I only just now noticed that mistake. Okay, so spaces adder equals some stone. Okay, that's okay. And we're going to come back to the game, and right here we are going to, oh no, we need one more layer of indirection. Do we? Yes, we do. The first thing we will do in this function is self.board.place stone, column, row, color, or stone. And then I have not anywhere stored whose move it is. That is ridiculous. Huh. Current player, color. Self dot match stone, self dot current no, color white, self dot current player equals color black. There we go. So that's going to change the internal state. But the thing that we never, or the thing that I've never done is I haven't fixed this. What is wrong with this? Place stone request is not at the root. What did I Consider importing. What have I done? API has playstone request. That's weird. So if I go to lib.rs, oh, I see. Okay. Pub use API. In Kifu core, the request. Oh, I didn't actually export. I'm not going to do that. I am, in fact, going to just get lost in my own app. I'm still in the wrong place. But I'm going to import the playstone request from this file instead of from the root of the crate. I don't know that that's the right thing to do, but it is what I'm going to do. As soon as I figure out where I need to be, because I have forgotten. Here we go. So we'll pull it from there. Cool. And now right here in playstone, we're going to call, we've got the game state. I'm going to call game.placeStone rec.column, rec.row. The request does not include the current stone color. Oh, that. Yep. Okay, well, I'll fix that at a different time. For right now, place stone on the game state just knows which stone to place. Self.currentPlayer. These fields are private. I will make them public. There's no need for them to be private. Now, I want to know what is wrong here. This is, oh, I still need to return the playing field. And this seems like as good a place as any, I think. So I've done the processing. Now I want to take the current game state, render it back into a playing field, which is something we haven't done at all. So this here playing field function was, I knew from the beginning, a placeholder. You can see all of those hard-coded values. Yeah, all of that's going to go away. Instead, I need to start querying the game state in order to do that. Well, I guess I'm going to leave the faked out player card elements and the faked out chat, but the board itself, as well as the current player. So playing field now needs to take what part of the game state do I want it to take? I don't want to give the entire app state. I know that there's a game in progress, so I think that what I want to do is just pass the game state into here. basically a snapshot. So I'm sending an owned value in. I'm not sure if that's actually the right way to just take a snap. In fact, I know it's not. So we'll send that in, and at the very least, I am going to just set the current player appropriately. Self.game.current player, which needs to be made public. Maybe just, it doesn't matter. Okay, that's feeling pretty good. That's not feeling so great. Let's fix that. Cool. Okay. Now I need to import the game state. Which is not properly exported yet. It's not the API. I keep forgetting exactly where to find these things. And it's in types. I don't feel like that's a good place to keep it. So the game state is published from here. Oh. There we go. That works. And now I can go back to the API, and this function needs to be given the game state. I'm going to come back to this one first. So the state is the entire app state. So and now I'm gonna this is fine. App state, whoa, take a reference, app state dot game, but only if it exists. Cheating right there. I should not unwrap. But I don't feel like I've got the state model actually handled well. So that's why I am going to do that. That's not... no method game found, but it's no longer a game. The field is private. Is it? I thought I made that... Oh no, I didn't make that public yet. So this needs to be mutable. That's fine. And then this right here, there's just a request for the playing field view. Let mute. Or no, I'm not even going to make this one mutable. Let app state equals self dot state dot read dot unwrap. Let oops. And I'm just going to take a reference to it. And I'm going to actually structure the code correctly. All right. I think I'm going to run afoul of the borrow checker here. Yeah, that's what I thought. Yeah, I'm moving things. I need to asref this again. Same here. And that seems incorrect. I think I need to do this. I think it should have been flagging that, but it's angry here. Create private type, game state used in public interface. Huh. Well, this isn't actually a public interface, so I'll semi-privatize that. All of that looks good. There's still a problem in mod.rs. Playing field is only public within the crate and cannot be re-exported. Yeah, okay, that's fine. Something's still not right. That should not be... I think that my understanding of what is public and what is crate public is a bit incomplete. So I'm just going to make everything public. Just kind of solve that problem. And there's going to be a whole lot of things that have the same... Oh, no, this one I just forgot to make public. And then player is also needing to be made public. And never gets used. That's fine. Okay, that actually built. So what we should see here, actually, is that when I click on a space, we won't see the board update, but we should see the ghost stone change. Oh, we panicked. Awesome. Oh, right. I know where that is. This is in the API, line 38. Because there isn't a game yet. Great. So I'm going to instantiate it with a game. This is going to be a bit easier when I get more of the state management of the application worked out. There we go. Take that away. We need a new function. I'm going to have to generate a whole bunch of fake data here. So board, game state, the board will be a board with a size, width of 19, height of 19. I really don't want to do that. Right. have to implement a board function or a board new function. The conversation is just going to be an empty vec. Current player. Black goes first in this game. The white player is a player whose name is savanni and whose rank is, this really doesn't matter, Q10. Is that okay? Yeah, I need to own that. And this is going to be Opal, who doesn't actually exist. That's okay. And then the white clock, duration, we'll say got 10 minutes left, so it's going to be from sex 600. Sure. We'll do the same thing for the black clock. Okay. I need to actually return the game state. Good, and now I need a new function for the board. And because there's certain things with vectors that I have a little bit of trouble keeping track of, I'm going to go see how I implemented this one. This is so ugly, but as far as I know, there isn't a way to just like pre-size a vector with a bunch of pre-implemented data. So here we go. Oh yeah, I see why I did that too. Doesn't have to be quite that complicated here. So the size, let's see here, self size 19, or width is 19, height is 19, and the spaces is a, I need to actually let mute spaces equal vec new, and then for I in 0 dot dot 19 times 19 spaces dot push none. Did I get that right? Close. Unnecessary parentheses. Okay. Expected option found struct. Right. Come back up here where I implemented the game state. Awesome. Okay. So we start out with a black stone. I click in a space. And now we get a white stone. So it's not showing that there are stones on the board. There technically is a stone on the board. But we are illustrating that, yes, the core is doing the right thing, in that it is processing that a stone has arrived, or that a click has arrived, a stone has been played, different player's turn. I am not, since we're already at 75 minutes, I am not going to implement that last step yet. I really wanted to. I'm probably going to implement it off screen, but it's basically a matter of taking this board data structure and then turning it into a board, basically populating the board element. And yeah, I'm probably going to do that off screen. So next week we're going to, I'm not actually sure what we're going to cover next week yet. Might actually be fully implementing the rules of the game, which will mostly happen here in the game state, here in the board, because there's going to be there's quite a lot that needs to be done, figuring out groups of stones, figuring out captures, figuring out illegal moves. But the fun part is we get to do all of that without modifying the user interface. So that's going to be cool. And that's really where we get to illustrate the whole power of being able to do this. Because once I've implemented the game state here, and I've implemented the code to convert from a board to an actual board representation, well, that's implemented for every user interface that I throw on top of this thing. So yeah, that draws us to a close for tonight. A lot of work to get a small thing done, but I actually do think that it's a very powerful way of doing things. So if you are still here, thank you for watching. Thank you for sticking with me, and let me know what you think. You can contact me on Mastodon or on Matrix, and I'll see you again in a week. Good night, everyone.